I'm Christine Angelini. I'm an assistant professor at the University of Florida, and I'm going to be talking in this video today about a Living Shorelines project that I've been conducting in collaboration with some of the researchers and managers at the Guantanamo-Matanzas National Estuarine Research Reserve. The purpose behind this project is to meet one of their immediate management needs. There's a lot of boat traffic in this estuary, and these boat wakes are really altering the hydrodynamics of this ecosystem. These are typically low energy waterways, and these boat wakes are just simply chewing away at our estuarine edges. So to slow this marsh erosion and facilitate the regrowth of oyster reefs, we've been conducting some experiments with a new type of living shoreline design. The whole purpose behind our living shorelines design is to have a sort of two lines of defenses protecting our shorelines from these boat wakes. The first are breakwaters that are the first line of defense as boat wakes sort of act on our shorelines, and then positioned behind them we're trying to jumpstart the recovery of oyster reefs to act as a secondary biological barrier. And in combination, the breakwalls and the gabions and oyster restoration structures are designed to sort of halt the erosion of the marsh edges and stabilize their position.
My name is Ada Versosa. I am a PhD student in environmental engineering at the University of Florida, and I am coordinating the research on this Living Shorelines project. Today we're going to show you how we built breakwalls along a 55-foot stretch of shoreline. Along this segment, we built 3 walls. Each wall was 14 feet in length, and the space between the walls was approximately 6 feet. And these are the measurements that we use for a stretch of shoreline that's roughly over 50 feet in length. To mark the position of the breakwalls, you have to measure 20 feet out from one edge of the shoreline that you've previously marked, and mark that spot with a rebar stake or a PVC pole. Then you have to measure 14 feet from that stake parallel to the shoreline and mark that end, and that will be the entire length of your wall. Then, using a mold or some sort of marker, you will then use the ends of the wall to position the fence post.
Using your PVC grid, you now have where you want to position the fence post for your wall. What we do in our group is first use the soil auger to mark the position of each one of the posts. So you'll just auger down basically 1 auger depth into the soil just to mark the position. Once you've marked the position of all 14 of the fence posts, you can remove your PVC frame and then come back to actually dig them out. So we typically use the soil auger to excavate down to a depth of 3.5 feet. Pre-opening the holes with a soil auger, we found makes putting the fence posts in a lot more efficient. You get through sand and clay layers depending on the substrate of your site. And once you've gotten your hole open to a depth of about 3.5 feet, you then take your fence post, again that has the tapered tip to it, position it in the hole, and pressure it down into the substrate using your own weight. Once you have all 14 of your fence posts in on your wall, you then want to return with your wooden mallet and pound these fence posts in till refusal. This is a really important step in the process because the fence posts are really what's bearing the wave energy that acts on these walls.
To fill these walls, we used branches that were roughly from 1/2 inch to 3 inches in diameter. They spanned a variety of length, but we preferred to use ones that could span the length of the wall. That would make them easier for them to stay put. We bundled the branches before bringing them out into the field just for easier transport, and we were able to carry these bundles and spread them evenly inside the fence posts in between the 2 rows of 7 fence posts that we built. And we made sure that branches were evenly distributed and that the height of the wall was as even as possible across the length of the wall. Once the branches are inside the wall and as evenly distributed as possible, you want a heavy person to step inside of the wall and actually walk on top of the branches to compress them. Once the branches are in the wall and compact, you want to use PVC coated wire and galvanized fence post nails to secure these branches. To start off, you want to tie the the beginning of the PVC coated wire around the first fence post, and you want this to be approximately 8 inches above the sediment. You want to knot it around and pull it tight and secure it with 2 fence post nails. Once you've secured the first fence post, you want to take the wire and zigzag it around the wall, making sure to secure it with a fence post nail at each post. And then once you reach the end of the wall, loop the wire back around, making sure to wrap it around the fence post that you missed.
If you want to use the bees for constructing your oyster reefs behind the break walls, here's a couple of tips for how to install them well. So the first thing is that you want to make sure that you alternate the pattern when you lay down the one bee sheet above the other, so that basically the direction of the V goes perhaps to the right on your first sheet and to the left on the second sheet. This is important because it makes sure that that the sheets directly overlap with one another and form a nice firm rectangle. To connect the bee sheets, it's really important that you go through and you connect each one of the click joints. So I often start in the middle and start from one end and work my way to the other end, and then work on the next row next to that, and just so that I'm sure that all of the ball and socket joints are connected through the whole sheet. To install the bees in the field, what you want to do is position them 10 feet behind the break walls, and we use 2 3.5 foot long rebar poles. These are 3/8 of an inch rebar poles that we bend an L into the end of, and you simply push them through the bee sheets into the substrate and position the end of them so that they fit in the grooves that you can see here on the top of the sheet.
I'm Matthew Monroe. I'm a biologist at the GTM Research Reserve, and this is how we're making our gabions. First, we're using galvanized metal, 1-inch diameter squares. We're bending them into 18 by 6 by 6 inch squares, and we're putting them together to cover a 24-inch by 18-inch area. Once they're cut, we have a wooden block that we use to bend them, and we're using hall clips to attach them together. Once all the metal is bent into shape and hall clipped together, we then take it to our shell recycling center and use shell to fill them. We have oyster shell here, anything would work that is natural material, and then we hall clip them closed. Installing the gabions in the field, we start by measuring 10 feet off the seawall, and we lay them out, spacing them apart about 1.5 inches. Once the gabions are in place, we put a little weight on them to set them in the mud, and we use zip ties to attach them together about 1.5 inches apart.